Hello everyone. In this video we are going to learn about the Haber's process and then some of the physical properties of this NH3. Okay. So you know that in the Haber's process whenever N2 and then 3 molecules of H2 when we are reacting there is a formation of NH3. So this process we are going to call it as a Haber's process. So how we are going to do exactly here is, see, we are going to pass a H2 gas and N2 gas here. So H2 and N2 we are going to pass and then we are going to compress these at a pressure of that is 20 M. Okay, that is megapascals. Now the question is why we need to use this high pressure or why there is a requirement of this compressor is, if we do not use a high pressure, no, these two gases they will not mix. So in order to mix them and to react, in order to get the product that is NH3, we are going to compress that. Further what happens is, for this we are going to use a catalyst. So the main thing why we are using this catalyst is the rate of a reaction will be increased. That is the catalyst molecule that will reduce the activation energy and increases the rate of reaction. You all know that. So the catalyst that we are using here is iron oxide, which is used in the high quantity, and a very small amount of Al2O3 and then K2O. You have to remember this catalyst. And then a high temperature condition is required here. A temperature condition of about 700 Kelvin is being used. Yes, we are reacting this and we are using this catalyst here. So what happens is N2 and this H2 they will combine and there is a formation of liquid NH3. So that we are collecting here. So in the reaction, no, there is not only this NH3, so all the N2 and H2 molecule will not be reacting to form a NH3, there will also be some amount of N2 and H2. So that unreacted molecule, again we are going to react, from this it will pass this N2 and H2, through the help of pump we are again reacting and then it will react with the catalyst, the same, and then the process will be continued. That is, the unreacted N2 and H2 will also be again passed and then we are reacting again and then we are forming a NH3 here. So this is how we are going to prepare this ammonia by the Haber's process. So what is very important here is there are few conditions that you have to remember in this process. The first condition is that we are using a very high pressure condition. Okay, that one you have to remember, that is 200 atmosphere of pressure. That is very important. Nothing but a 20 megapascal. The second one is we are using a high temperature condition for this. That is also very important. That is a high temperature condition, that is 700 Kelvin of temperature. Very important. The third important condition that you have to remember in the Haber's process is that is catalyst. So what catalyst we are using here is, that is iron oxide and then Al2O3 plus K2O. So these three are the very important conditions you have to keep it in mind. Okay. Next, the next thing that we are going to study is the properties of this NH3. As you know that the nitrogen, which is having a lone pair of electron, so the lone pair of electron on it makes it as a Lewis, that is anything which accepts the H plus ion here. So because of the lone pair of electrons, it will accept H plus ion. So it is having a 3 bond pair and then 1 lone pair. Okay, you have learnt the geometry of this in the chemical bonding. So geometry of this is, that is trigonal, pyramidal, very important. And then other properties of this NH3 are, this is soluble, that is highly soluble in water. Okay. The second one is the aqueous solution is weakly basic. Why it is weakly basic is because of the formation of OH minus. As you can see in the reaction here, NH3 plus water, that is aqueous solution of this, that is NH4 plus and OH minus will be formed. As a result, this is little weakly basic. Now, why it is highly soluble in water? You know that it is when we compare the electronegativity, no, of this oxygen and the nitrogen. Okay, so the nitrogen is having a more electronegativity compared to oxygen. As a result, there is a formation of hydrogen bonding there. So there is a high solubility, one thing. Second thing is, because of this hydrogen bonding, there is a formation of strong intermolecular hydrogen bonding. As a result, what happens is the boiling and the melting point of that will be very high. So why is this? Because of this hydrogen bonding, we require more amount of energy to break that bond. More amount of energy in the sense we have to supply high temperature. So that is why it shows a high boiling point. So these are the basic properties of this NH3. Okay.